Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back revisiting our old friend, the Nobsound 6P1. And we've done some modification videos on this little amp. And this one's going to be a very different type of video series. And I don't even want to call this like a mod video, because this goes way beyond like modification. This is basically building a new amplifier, but using this chassis as the starting point. And we're going to be reusing the power transformer and the tube sockets and the stuff in the front, the speaker jacks on the back. But that's about it. The rest of it's going to be just gutted and start over. I really feel like this amp has multiple problems that a simple mod is just not going to address. The first thing is the milliamp rating of this power transformer is inadequate for driving 4 output tubes, which is what this amp has. And I'm sure they realized that pretty quickly when they tried to bias those 6P1 tubes up at the right dissipation level for a parallel pair of them. It just melted the power transformer. And so they soft biased these to the point where it's basically the bias point of what a pair of tubes is. They claim it was 6.8 watts, but they were just going by adding up what was on the data sheet, not by measuring the amp. Out of the box, I believe it made less than a watt before it went into like pretty heavy distortion. And I mean, it did use 6S and 7 output tubes, but it had this weird cascode thing that actually worked really good for something like my 300B amp, but totally unnecessary for the amount of drive needed for these tubes, and just was a whole bunch of unnecessary complication. Also, by using these parallel tubes, they ended up having to use 2.5K output transformers, which really limits what can be done as far as changing it into some other kind of amplifier, or making it just a pair of tubes, because you can't just do that, because you need all 4 output tubes to match the impedance of these output transformers they put on this guy. And so there's some tricks we're going to try along the way. I did order a pair of these little budget bile cow, whatever things they call them on Amazon from China, little 5K output transformers that are the sister to these 2.5K, so we can put actual 5K output transformers and have a 4 and an 8 ohm tap, because it's a multi-tap deal. One thing we may experiment with along the way is see what putting an 8 ohm load on the 4 ohm tap of the ones that are on the amp perform like, and compare them to these, and see if we can get away, or you could get away with not having to replace the output transformer. And then I also have a pair of these musical power supply 8 watt. These are supposed to be 5. These are 8 watt output transformers that have a 5K or 7K impedance, and they have a, let's see, they got a 4, 8, or 16 ohm tap. So we'll see what these perform like. And we're basically going to use the circuit that Dave G on Audio Karma came up with for this little Magnavox amp. And it uses EL84 tubes instead of the 6P1s, and we're going to go with these EL84 tubes just because that's a known circuit that works. They're going to be wired as a pentode instead of a triode strap tube, so it'll make more power. It's got global negative feedback, and for the driver tubes, he had used a 12AX7, but we've got a pair of these octal sockets, so we're going to go with a 6SF5, which is an older single triode octal tube that has the same specs as a 12AX7, and so kind of fills up the tube sockets. Probably going to go with a solid state rectifier replacement. May leave the socket wired up like it is for folks that want to put a tube rectifier in it, but putting a solid state rectifier on it takes 2 amps of load off of the power transformer that would have to power the heater, and it bumps up the B plus and makes the amp just more reliable. But hey, we can try it both ways, maybe even listen to it with both, and it gives you the option of that. Other big problem that this amp has is, and it's written on the bottom of the power transformer, it's got 110 volt primary. And in the US, most of us have 120 to 125 volts. That gets the heater voltages higher than the tubes can stand. And when you get the heater voltages from 6.3 to like 7 volts, you severely shorten the tube life. And so one of the things we're going to be doing to bypass having to run a bucking transformer or some other way of bucking down the voltage from 120 to 125 down to 110, probably going to put like some power resistors in the heater circuit to bleed off some of that voltage. And that's what these back tube sockets that you can see here, there's a pair of tube sockets back here, that these are going to be removed, put some screens in here, and allow like ventilation for those hot running bleeder resistors or voltage dropping resistors to be able to vent out the top of the chassis. And that way you can just plug this thing straight into the wall, and you don't have to worry about having some sort of bucking transformer to get the voltage down. The other thing we could try is putting a thermistor in the AC power line going in, or even put a resistor, just a plain resistor in the AC line going into the power transformer to drop the voltage that way. And we're going to do something so it doesn't need to have a bucking transformer. It can operate on 120 volts. So yeah, this is basically going to be a way for you guys to build an amplifier without having to fabricate up a chassis. That you're basically starting with like a prefabricated chassis, and you're going to be putting a completely new circuit in it. So we're likely going to be just gutting the inside of the amp and like taking all the wiring out, except for maybe leave the wiring for the rectifier tube in, but everything else we're going to just gut and figure out how we're going to wire up the new circuit inside the amp and end up with a pentode that I think this thing makes about 5 watts, which, okay, it's not what the spec said, but it's way more than even a modded version of this 6P1 makes. And that circuit gets rave reviews from a lot of people that have built it. There's a long thread on Audio Karma about this circuit. I'll link it in the description. This is what the circuit looks like. As you can see, it's not real complicated, and it's a really great starter amp for somebody to build. So for you guys that have one of these little, they were sold under various labels, you'll recognize the amp if you got one of them. And if you've been itching to DIY build an amplifier, but the idea of fabricating a chassis from scratch was intimidating, this is a way for you guys to get your feet wet building something, and the joys of actually a from scratch built amp. And again, this isn't, I wouldn't call this a mod series. This is basically a DIY amp build using a prefabricated chassis. So anyway, I know this has been a long time coming. I hope this is going to be a pretty quick build, because it's a pretty well-known circuit and we're not deviating from it really at all. I'm going to try to nail all the test points, what's in that circuit in the series, so that we know we've got the right impedance transformers and all that stuff, that everything's going to work out right, and it should be a good sounding little amp. So if you think you'd enjoy this series, please subscribe to the channel. If you haven't, please like the video. Thanks to all you folks that are Patreon members or members of the channel, make donations at my website, and thank you to the patience of the viewer that sent me this. Legit, it was probably 2 years ago, and they've never said a peep. And so, finally getting to your amp, John, and hopefully we'll get this thing done before the summer, and you can get your little amp back. So, anyway, until the next video, have a nice day.